Hey, welcome everyone to the latest installment of the Metal Architecture webinar series. I'm Paul Deffenbaugh, the editorial director at Metal Architecture magazine. We've got a great presentation for you today on cladding safety in light of global fires. This is an extremely important topic, and a panel of experts gathered here to help walk us through what all this means. In a moment, I'm going to bring in Tom Seitz, who's the executive director of the Metal Construction Association's MCM Alliance. They're presenting this webinar. He'll do an introduction, and then I'm going to come back and moderate the panel discussion. The panelists will answer questions at the end of the webinar, but please use the control panel on the screen to submit your questions as we go along. It's best to do it while you think of it rather than wait until the end when a rush of questions tends to come in. This presentation was made possible by the MCM Alliance and MetalCon Live. Mark your calendars for October 12th through 14th to be in Indianapolis for MetalCon, the trade show for the metal construction industry. In the meantime, go to metalcon.com and check out all the live events they're hosting. Those good folks have put together a ton of great education that you can access now. For those of you who need to earn AIA credits or certificates, you will receive an email a couple of hours after the webinar with a link to an online form. Complete the form, and your AIA credits will be submitted in about 2 weeks. You can also download a certificate of completion there. Please look for that email in a couple of hours. So, but for now, let's get started. Let me bring in Tom Seitz. Tom, are you ready to go?
Yes, I am, Paul. Thanks. We're glad to be here for today's Metal Architecture webinar. As Paul said, I'm Tom Seitz, the Executive Director of Metal Construction Association's MCM Alliance. And probably your first question is, what is the MCM Alliance? Well, we're part of the MCA and a group of MCM leading manufacturers, fabricators, and suppliers of MCM materials and systems for the North American architectural market. We're proactively working together to provide the construction industry with product performance testing, MCM-based research papers, and we're participating in all of the International Building Code compliance forums. Our ongoing mission is to help educate architects, consultants, code writers, and building owners on the MCM's advantages while ensuring the future of MCM in the North American architectural market. The next question that comes to mind, what brought this conversation to have a webinar on cladding safety in light of global fires in the first place? And let me just, well, too many global high-rise fires, just to mention a few. Tamwheel Tower in Dubai, Marina Torch in Dubai, recently the Torre de Motto in Italy, and of course, we all know the results of the Grenfell Tower in London. None of these, let's see here, let me just get this. None of these wall assemblies as installed would meet North American building codes. In other words, we're not just lucky in North America. Luck isn't really needed when you're working hard, doing the right things. Our MCM industry is a growing one, and one of our missions is to help educate the construction industry on what our testing has done to earn that trust. There's a lot of value for an MCM facade, and it comes in many different ways. It's design versatility, which architects are using every day. It's an amazing product. Its functionality as a lightweight and flat material feeds into that design versatility. And the testing beyond approach. We have tested this material constantly over the last 40 years. The purpose of this webinar is really to understand the value in the North American building codes. More specifically, the value of the NFPA 285 multi-story fire test and its overall performance of a wall assembly in the real world. The NFPA is all about safety and no threat to life. And the NFPA 285 tests the construction wall assemblies containing combustible materials for those real world applications. Let's get to So today's AIA HSW credit learning objectives are, what does the NFPA 285 tell us about cladding performance? The understanding of the materials relationship in that wall assembly for the cladding performance. They all tie together. When the 285 actually applies per the International Building Code requirements. and why engineering evaluations are really a great alternative to an actual test. And number 5, what trust in the NFP 285 means to you, the architect, the owner, the code writers, the local code officials. Now, I'm going to turn this program back over to Paul, but before this discussion, to moderate the discussion on cladding safety in light of global fires. But before I do that, I'd like to make one request. At the very end of this program, please stay on for a brief survey, as we would appreciate your feedback. And if you have any questions, please, like Paul said, put them in the Q&A, and we'll be getting to them at the end of the program. Thanks again for being here. And Paul, it's all yours.
Thanks, Tom. I'm really looking forward to what should be a great and knowledgeable discussion today, and that's because we have a great panel of experts. Dan Martin is a fire protection engineer with Jensen Hughes. Andy Williams is the Metal Construction Association's Director of Codes and Standards, and he serves as the technical advisor to the MCM Alliance. Nick Scheib joins us from 3A Composites, where he serves as Vice President of Sales and Marketing. And of course, we also have Jeff Henry, who is the CEO of CEI Materials, a company that fabricates MCM. Thanks to all you guys for joining us. Appreciate it, your time and your efforts here. With such an array of talent, you guys are going to want to ask a lot of questions. We keep pushing this. Ask your questions. We're going to answer them at the end of the webinar. So we're here to discuss cladding safety in North America in light of global fires. So let's start there. Internationally, in the past decade, as Tom said, there have been several large and catastrophic fires, and that's made designers, architects, code officials question if we are at high risk here in North America. In particular, the Grenfell fire in London, which killed more than 70 people, has had disastrous results. With this in mind, I want to ask each of you, help me understand if we need to be worried here. Dan, is this something we need to be worried about?
So Grenfell Towers, before I begin into an answer here, Paul, I just want to let everyone know that's on this webinar is that the government's investigation in England regarding this fire is still ongoing, and they've actually only released phase 1 findings. Phase 2, they're still going through the testimony and document review right now. But the short answer to this very loaded question is that the exterior wall assembly for Grenfell specifically was constructed and designed in such a way that it was not compliant with the building regulations of England. And when it was tested by BRE to the BS 8414 test after the fire, it failed. So the exterior wall incorporated 2 different types of exterior insulation. It had a polyiso and a phenolic. The MCM veneer had a polyethylene core or a PE core without any flame retardant additives, or FR. The cavity barriers that they require in the UK were not continuous behind the veneer, and the exterior wall geometry itself created some very large gaps between the insulation and the MCM panels, along with a whole slew of other things within the building that were an issue.
Thanks, Dan. I think with your expertise in fire engineering, we're going to kind of call on you quite a number of times today, and appreciate that update on the Grenfell results. And Andy, you're our MCM code expert on this panel. Can you explain if this type of assembly would meet the requirements in the IBC or the NBC that we follow in North America?
Well, thank you, Paul. The simple answer to that question is no. Back when the large-scale tests were first introduced, there were also a number of smaller-scale tests that the PE or the polyethylene core MCM couldn't qualify for. This was really the birth of the FR product. Today, pretty much in order to meet the code on almost all high-rise construction, the product that's used is the FR core material, and the assembly that the material is involved in meets the requirements of NFPA 285.
All right, that helps us understand how the Grenfell tire couldn't meet our building code in North America. Andy, what about the other fires, like the ones in Dubai, and actually one of those buildings is called the Torch Building and has burned twice. Would those have met our code?
Yeah, an unfortunate choice there of name, but actually the answer is still no. the PE core panels were used on all of these other products. And if the products would have been built in North America, the PE core would not have been allowed. FR core would have been used.
Nick, 3A Composites manufacturers MCM panels. MCM material? Can you speak to the PE core material and is it specifically, is it still available in the North American market?
Yeah, Paul, that's a great question. So the PE material is still manufactured and available in North America, but it's primarily used for signage and canopies, and it does still meet the code requirements on low-rise buildings under certain conditions, so that is true. That said, most manufacturers such as 3A primarily produce flame-retardant materials, and this is the predominant material used for commercial construction due to the fact that it meets the North American building codes and specifically NFPA 285 or S134 in Canada, respectively. We really encourage the market to design with the FR material and FR core because it helps reduce any risk should there ever happen to be a fire.
Now, you say, should there ever happen to be a fire? And so have there been significant fires with the MCM in North America?
Yeah, again, that's a really good question. And as Andy stated, none of those international fires would have would have been able to happen here in North America, and they wouldn't have met the North American building codes. So when I was first asked to be part of this panel, I had my team do research to find out if we could find any examples of fires in North America that had flame retardant materials on the facade and how they fared out in that fire, just so we could speak to it. We were able to uncover 4 fires in total, and they're here on the screen. You know, from one in Virginia, I found one in Ohio, we found 2 in Vancouver. And the interesting part about it is these aren't really heard of because they were very insignificant. On all 4 of these incidents, there was very little flame spread, very little damage. The fire was quickly and easily controlled, and there was 0 injuries. Ultimately, Paul, the wall assemblies did exactly what they were designed to do. They were designed to meet the North American building codes and the requirements of those large-scale tests, the NFPA 285 and the S134, and they performed very well in these real-life examples. Again, none of these fires really made the news because they were non-events. No injuries and very little damage.
Thanks, guys. You make some great points, and it seems like the NFPA 285 is a major key to understanding why North America hasn't suffered these catastrophic fires. And Andy, turning to you on the codes, is this code the same for both Canada and the United States? And is it the same for every state, every city, every municipality?
Well, that's a good question. And with regard to fire, the intent is the same, which is to limit the flame spread up the outside of the building. In the United States, as has been mentioned several times, NFPA 285 is the large scale test that's used. In Canada, you've got the ULC S134. There are differences between the 2 tests, but at the end of the day, it's all about flame spread on the exterior. Another common thing about the codes in the United States and Canada is, generally speaking, the codes are adopted across the entire country. Each state or province adopts that nationwide code, and they make some changes in it to address specific considerations or specific concerns in their area. To make things even a little bit more confusing, though, the major cities like Toronto, Los Angeles, Chicago, New York, they have local issues that they have to address. These are referenced as local amendments. And things like in New York City, the proximity of high-rise building to high-rise building makes them look at things a little bit differently. But the bottom line is that the flame spread over a building or between buildings remains the major concern.
Thanks, Andy. So as I'm understanding this, the code's different in Canada, but the S134 is a similar test to the NFPA 285. And its requirements by state and city may differ slightly, but the NFPA 285 is the most common requirement. And so for the sake of this presentation, we're going to focus in on the NFPA 285. With that in mind, Dan, can you tell us a little bit about the history of the NFPA 285 and cladding performance?
I mean, in reality, how much time do we have here? Because honestly, it could take me a day, a week to sum up everything we've kind of learned over these last 40 years, let alone try to fit it into this our presentation. But if I could define the work that's been done and what we've learned, it's been a massive undertaking by everyone over the last 40 years. Architects, manufacturers, the testing labs, engineers, building owners, developers, we've all worked together to try to make sure we have good, safe products out there that meet the code. We've done thousands of tests with thousands of different combinations of exterior wall assemblies over these last few decades. And all this testing has really left us with a strong understanding of fire performance and flame spread of exterior walls and how those materials burn.
So Andy, what's the NFPA 285 tell us about cladding performance?
Well, the 285 gives us a real world, at least size-wise, sample for a fire test and shows how the components, but more importantly, the overall wall assembly performs. NFPA 285 is about more than just the cladding. Items like combustible insulation, the geometry of the assembly, the depth of the air cavity, even the weather-resistive barrier can change the performance of the wall, and they're all included in the overall evaluation.
So the test has been around for about 40 years. A lot has changed in the construction industry. I'm going to guess this in that time period, and I'm going to guess that this test has changed a little bit as well. Andy, what's changed in the last 40 years?
Yeah, it has changed quite a bit, and you see a timeline in front of you right now that really shows how we've progressed since the 1970s. And what this timeline, while the dates are important, the real reason is it shows that we're interested and we're concerned about flame spread of a combustible wall. There's 4 real main reasons for changes to the standard. We want to increase consistency, we want to increase safety, we want to decrease the amount of time it takes to prepare the test, because there are a very limited number of facilities that can actually even run this. And we want to keep the test at a realistic level of difficulty that we've proven to be adequate over the last 20 years. Some of the examples of change include changing from wood crib to gas, moving the test from outdoor to indoor, and these changes were all made to make the test more consistent. There are several variations of large-scale testing throughout the world, and they involve different fire sources, different wall sizes, and even different test durations. But what we know here in the United States, after over 40 years of testing of MCM wall assemblies, is that a MCM wall assembly that is successful in the NFPA 285 has never performed badly in a real world fire, and that the flame spread is limited basically to what we've seen on the testing. Tons of information. I could expand like Dan a lot more, but this is kind of where we are and how we got here.
Great. Thanks, Andy. You mentioned the word combustible. I think, Dan, you have referred to the combustibility a couple of times. It might be helpful for I think us to understand that word a bit more, as it can kind of have a scary connotation. Dan, what does combustibility mean when it comes to building materials and the IBC code language?
So, Paul, interestingly enough, the good book, the IBC, actually does not have a definition for the term combustible. You go to the definition section, it's not there. So therefore, we've got to go to Webster's dictionary, and that's where we get our definition. But in terms of determining if a material is combustible or non-combustible in the eyes of the IBC, we go back to ASTM E136 or ASTM E2652. Those are the 2 test standards that are used by the IBC to determine if a material is combustible. Will it burn? Will it ignite and combust and generate flames? Ultimately, if you fail ASTM E136, you are considered a combustible material in the eyes of the code, unless you meet certain exceptions in IBC. And one of those examples is gypsum wallboard.
Gypsum wallboard, can you give us some more examples of non-combustible, combustible materials that are commonly used?
Yeah, absolutely. So as you can see here on the screen, we've got a whole slew of different materials that are considered non-combustible and combustible. I mean, concrete and steel, I mean, that's pretty straightforward for the non-combustible realm. But if you look in the combustible products, you get foam plastic insulation, water-resistant barriers, furniture, carpet, polyethylene MCM, FR MCM. I mean, you've got a whole slew of things here, and they don't all burn the same. Everyone burns a little bit different.
So we've got combustible materials around us, and we use them a lot every day.
Yeah, that's correct. We've got them everywhere. The clothing you're wearing is combustible.
All right, so but they're not all the same. They don't even each have the same amount of flame propagation potential, is that?
So yeah. All materials are not the same. They all burn a little bit different. Flame propagation and combustibility, those are two completely different things when you're trying to look at a material and evaluate it. Like I said, every material ignites and burns differently, and we need to evaluate it in that way. So in some instances, the combination of two different burning combustible materials will result in a flame spread that is completely different than if we were to burn those materials by themselves. And I'm going to repeat that real quick. A single burning item will have a certain amount of flame spread. But as soon as we add a second combustible material and we add in geometry, air gaps, angles, whatnot, that will completely change the fire performance and the flame spread of those two materials burning together.
Thanks, Dan. Nick, let me turn to you. Your company manufactures MCM, and in particular, I know 3A produces Alucobond Plus, which is FR. Explain what the FR means and how it's different than the PE and that have been used in the fires, the fires we've seen so far. The PE was used in the fire. Sorry, I garbled that question up.
Yeah, no problem. Yeah, sure thing. So first off, FR stands for fire or flame retardant, actually, not fire resistant, which is commonly confused, but it is an important difference. The flame retardant core not only burns more slowly, Paul, it actually retards the flame due to how the core is made.
So how is it made? What's the composite that causes this fire retardant characteristics?
Yeah, so I'm not a chemist, but on the screen here, I think it will help me and everybody in the audience here know what I'm speaking to. So number one, manufacturers of MCM use different minerals and different proprietary cores, but primarily there's two main minerals, fire and flame retardant minerals that get added to the core. The one that's commonly used is aluminum dihydride. The other one is magnesium oxide. And when these minerals are exposed to extreme heat, they actually break down and release water vapor and some gas. Fortunately, the gas is non-toxic, so that's a good thing. And the water vapor, we can all imagine what that does. That helps suppress the fire, and it actually allows the material to self-extinguish once the flame source is removed. So as soon as that fire source, so to speak, if you take the match away from the material, it will immediately go out.
Thanks, Nick. So we've been kind of talking about the NFPA 285 test quite a bit here, mentioned several times already. I think it's going to be beneficial for us to get into this testing procedure a bit more. And Dan, we're going to come back to you. Let's start with the basics. What's the NFPA 285 determine?
So NFPA 285 is the standardized fire test method for the US and IBC, and it helps us determine vertical and horizontal flame spread on exterior walls that contain combustible components. Like I said before, we're evaluating flame spread. Now we're evaluating it in a couple of ways. We're looking at it across the face of the wall. We're looking at the flame spread within the wall cavity in spaces that we can't see. And we want to ensure we don't have flame spread from floor to floor within the building via the exterior wall. So limit wise, we're looking at flame spread is maximum it's allowed is vertically 10 foot above the window or the wall opening. And then if we look laterally on the test apparatus, it's 5 feet to either side of the center line. So 10 feet up, 10 feet wide, 100 square feet is your maximum fire size here. And the key word to emphasize here is assembly. This is an assembly test, not a component test. And it's right there in the title of the standard. We're looking at all the components together.
Thanks. How's the test set up, Dan?
So the 285 test, as you can see here on the screen, it's a multi-story apparatus. We have two levels involved, the lower level being the burn room, the interior fire that we're trying to simulate a fully developed fire, or what we would consider a post-flashover fire, where we'd have a fire plume breaching through the wall opening, and we achieve this via two burners for safety reasons in the lab. We have the burner in the room, and then we have an exterior window burner, and we're exposing the interior face of the wall and the exterior face of the wall to fire at the same time. The test assemblies themselves, the samples, are built into a frame and they can roll into place against the face of the test apparatus. So that allows us for multiple tests to be run with multiple downtime. We can prefab these walls, roll them in, roll them out. We just got to let the furnace cool. And then these tests can be quite smoky. So when it's smoky in the lab, we're trying to look at flame spread in concealed spaces too. So how do we do that? We've got thermocouple measurements or temperature measurement devices within the wall assembly, on the face of the wall, inside the wall, at several locations within the assembly, and in the room above the burn room. And we're looking at temperature readings, and based on the standard, we have temperature thresholds like 1,000 degrees Fahrenheit to tell us where the flames are at within the assembly.
You mentioned that this is a 2-story test. So how is the second story involved in the pass?
Yeah, that's correct. So as I said, we're looking at flame spread vertically within the cavity and then from floor to floor. So the IBC, the intention of the code is to ensure building safety and life safety of the occupants. So we want to make sure that the people on the floor above aren't exposed to flame or heat or smoke, and it's not allowed to enter the second story. So there's a couple ways a fire can get into the floor above. It's at the slab area where the wall interfaces with the edge of slab. You can get fire that breaches out the window, burns up the face of the wall, and tries to breach back through the entire cross section. Or you have fire that gets into the wall cavity and then breaches through to the interior as well. So there's temperature measurements and video cameras in that second story to make sure the fire isn't burning through the wall and getting to the floor above.
So if the flame and intense heat spread 10 feet or beyond, it's a failure, as I understand it. And if you only use non-combustible materials, such as solid concrete, how high does the flame and heat spread?
So if I just had a concrete wall and I run the test, no combustibles involved. As you can see here in the image, the window burner and the room burner, there's no sample in this photograph. But that flame from that window burner you see right there will go up about 6 feet and reach about 1,000 degrees at that 6-foot mark above the wall opening in the apparatus.
And Dan, you've described this as an assembly test, and what does an NFPA 285 assembly test mean, and how is that different from a product test?
So on the screen you see here, we've got a generic cross section of an MCM panel system. We've got interior gypsum wallboard on the far right, studs, exterior gyp sheathing, exterior insulation, water resistive barriers in there, and then the MCM panel. So when we're doing this test, we're evaluating the exterior wall assembly as a whole and not as a singular component. As I said, we're looking at everything from the interior wallboard all the way out to the veneer system and everything in between. And as I've discussed before, when you burn a single burning material, it'll behave in a given way. But as we start to burn multiple materials together in a specific configuration, that flame spread and burning behavior will dramatically change. In a product test, the only material burning, like I said, is itself. So running a 285 test, for example, on a single combustible item like an MCM panel on a gypsum base wall, so gypsum stud, gypsum nothing MCM panel, that's only going to give us the performance of the MCM. But when is the MCM panel going to be the only combustible in the assembly? I mean, what about the water resistive barrier? What about our continuous insulation requirements by the energy code? Just having an MCM panel only NFPA 285 test doesn't really give us an end use assembly to determine if it's NFPA 285 compliant or not. So the test has to be conducted with all the exterior wall components involved.
Great, thanks, Dan. I think it's probably helpful for us to see one of these tests at this point. And Nick, I think you have a time-lapse video that will take us through the test from the beginning to end. Let's cue that up. And Nick, would you talk us through what we're seeing?
Yeah, absolutely. I think it is very helpful to see one of these tests for anyone in the audience who hasn't had the opportunity to witness one. It definitely helps you understand how intense this test really is. So right here, before we begin, just to understand what you're looking at, just like the images that Dan was covering off recently. This is a 2 stories high test. And you can see here in the front that opening window. What you see in what's behind there is actually that big open room space where the fire is, and then you have the burner on the outside of the window. So this is going to take us through 30 minutes plus a 5-minute cool down of the test afterwards. It's just going to be sped up so that we can watch the whole thing happen in very fast, but it's going to be continuous. So if you can go ahead and start the video. You'll see here, they light the interior, so that interior room is heating up to 1,000 degrees, so lots of flame there. And here in a moment, you're gonna see it flame up really high, really suddenly. What really happened there was they lit the outside burner. So as they lit that outside burner, they're pumping gas through there, increasing the BTUs throughout the entire test to increase the intensity of the fire, because that really simulates a real life situation. You can see the flames reaching up as high as 6 feet. And as Dan mentioned, even if there was nothing but non-combustibles on the wall, that's how high the flames reach. So it's actually melting and slightly burning some of the core, but melting the aluminum out of the way as the test carries on. And again, they're actually adding more and more heat, more fuel to this fire as the test is going on. So here shortly, we'll hit the 30-minute mark. And you'll look at this here, and right there, they actually turned off the gas. So what's really important to notice at this point in time is there's no fire extinguishers, there's no sprinklers. All that happened was the flame source was removed, and the material responded exactly as it was designed to. Its FR property actually caused it to self-extinguish without anybody having to address it with something such as a sprinkler. So this was a successful pass of a test. As you can see, it's an extraordinarily intense test, and the material on the wall performed exactly as we would expect it to.
Thanks, Nick. Dan, so it's an assembly test, but the individual components of the wall matter. Tell us about the weather-resistant barriers in the insulation. How can the selection of these materials impact the NFPA 285 testing? And in particular, are they all pretty equal, or does the particular type of material chosen matter?
Yeah, so for starters, there are several different types of water-resistant barrier manufacturers and products out on the market, and the same holds true for the insulation materials. These materials traditionally kind of cover the entire wall assembly, and it can account for a large amount of the combustible material within the wall assembly itself. Now, just because they're not visible from the street doesn't mean that we can ignore them completely. They all physically burn differently, and they all have different intensities of burning. You can get water resistive barriers as fluid applied, so it's kind of sprayed on or rolled on with a paintbrush. You have the self-adhered sheet goods, and you have the mechanically fastened sheet goods with staples or screws. And based on our in-house cone calorimeter testing, we know that the fluid applied materials tend to burn a little bit longer because they're thicker, and they burn a little bit hotter. They got more beef to them when it comes to their combustible components, and they have more potential energy than if you look at the mechanically fastened sheet goods. So usually when we're conducting a 285 test and we're trying to extrapolate data later on in an engineering evaluation, which we'll cover later, we want to test with a highly combustible material that has a lot of potential heat involved. So from an insulation standpoint, we're kind of looking at the same thing. The insulation's a little bit different. They vary from spray foams, EPS, XPS, polyiso. You don't see a lot of phenolic foams here in North America, but then you also get the mineral fiber insulations. So some of those materials, when they're heated and burned, they'll melt, they'll drip, they'll ooze. Some other materials will burn slowly and create a char layer, a little bit of a crust to it. And then you look at the mineral fiber insulations that'll just slowly decompose as they burn. But based on our years of testing at Jensen Hughes, we know that specifically with MCM panels, spray foam, EPS, and XPS foam insulations do not work behind MCM panels. So if you give me a call and say you're going to use spray foam behind the MCM panel, I'm going to tell you to save your money. You're not going to pass the test.
Thanks, Dan. That's a lot of really helpful information. Appreciate it. And so, but I kind of switching gears now. I'm wondering, how do we know when testing is required? And Nick, can you help us understand what triggers the NFPA 285?
Yeah, Paul, it can often seem quite confusing as you go through the code. NFPA 285 is actually referenced in two different sections of the code. One is in chapter 14, and that's for facades. The other is in chapter 26 for insulation. And again, like I said, when you're reading through it, it kind of references you back and forth. It can feel like a bit of a maze, but there are a few easy questions that you can ask yourself when designing a building or a wall assembly, so to speak, to get you going in the right direction. And at 3A Composites, we developed a quick, easy decision-making tree, and that's what you see here on your slide in front of you. And we could go over this, but I'm actually going to hand this off to Jeff Henry, who is a fabricator, and I know he and his team and fabricators alike go through this type of questioning with their clients often, and so I'll let him walk us through this framework.
Thanks, Nick. Thanks, Nick. Yes, as the MCM fabricator, one of our jobs is to ensure that the wall assembly meets code. The first parameter to consider is construction type. If it's non-combustible construction, that's types 1, 2, 3, or 4, then NFPA 285 must be considered. Next, I look at what's going on behind the MCM system. Is there insulation outbound of the sheathing? And if so, what type? If it's a foam plastic insulation, as Dan alluded to a couple slides ago, then an NFPA 285 is required. If there's no insulation outbound of the sheathing, then I look at the height of the building. Simply put, if the building is 40 foot or more above grade, then NFPA 285 is a requirement.
Thanks, Nick and Jeff. On all that seems pretty straightforward. But I noticed you mentioned some exceptions. So Jeff, what do you recommend to the audience if they have questions about their wall design?
Well, I recommend anyone to reach out to your local MCM fabricator or MCM sales representative. We're here to help answer your questions. Beyond that, the MCM Alliance and our own code expert, Andy Williams, can help answer your questions as well.
So we've covered the NFPA 285 in quite a bit of depth here. Jeff, are there any other building code requirements related to fire for MCM cladding?
There is, Paul. ASTM E84, often referred to as just E84, is a standard test method for assessing surface burning characteristics of building products. It's a test that's been around for decades, and it measures both flame spread and smoke developed of individual components used in a wall assembly. The results of this test classify a material as either type A, B, or C. Class A material is required for high-rise construction, and materials that do not meet this classification often have difficulty passing NFPA 285. The downside of E84 is twofold. The test is horizontal, and we know that critical performance is determined when the material is in a vertical orientation. The test is done on individual wall components, and again, as mentioned earlier, there's no way to determine fire interaction of individual components using this test. So again, we look to NFPA 285 as a great test to determine the performance of the wall assembly.
Thanks, Jeff. So Andy, I want to come back to you. You've been in the industry and part of the MCA for a number of years. What has the MCA and the MCM Alliance done for the safe use of MCM?
Well, Paul, both the MCA and the entire MCM industry are really focused on performance and safety. Probably the best example I can give of changes that have been implemented because of the MCA and the MCM industry goes back to the initial IBC code in 2000. When we first wrote that code, there was a section in that called alternate conditions, and there were some exceptions to the use of NFPA 285, very limited exceptions, limited in scope, limited in the spacing, mostly used for things like signage and that type of thing. But that was in there, and it allowed the use of MCM, the PE core MCM, above 40 feet above grade. After 15 years in the code, this section still proved to be a problem for architects and designers to really adhere to and get the intent correct. In the development of the 2018 International Building Code, MCA proposed that this section be removed, even though we were the ones that got it there in the first place. The change was very welcomed, and that change took place in the 2018 code. So those allowances above 40 feet were no longer there unless you had a 285 test. Another development by the MCM industry that started back in the 1980s was something called an acceptance criteria for MCMs, or AC25.
Tell us more about the acceptance criteria 25, Andy.
Well, what we found is that there were a number of manufacturers for the ACM or the MCM materials, and we had to have some kind of a measuring stick to compare these products in performance. It's what started off as a 1-paragraph criteria to this, at this time, is 17 pages long, and it includes quality tests, physical performance, fire tests, and it's used by the code people in the MCM recognition reports. In addition to the acceptance criteria in the building code, there's a call for product labeling and third-party testing. The product labeling is a way to get the information about the performance of the panel out to that field inspector, and the third-party testing ensures that any testing is done at an independent laboratory and is done in a standardized fashion. There's lots of details included in that 17-page acceptance criteria, but we do find that it's the best way to compare the MCM products in the field.
Nick, Andy mentioned IBC and the AC25 require labeling. As a manufacturer of MCM, can you tell us what these label requirements are and why they're so important?
Yeah, Paul. So the IBC sections 1406 and 1703, we're required to provide a print line on the back or some identifying marker on the back of every panel. We really need to identify the product name, the total thickness, and the identifying labeling program of the product. This is really important because it allows the fabricator or anyone really to identify the material both during the initial construction and then after the construction, should there ever be a need to replace materials or have an inquiry on what the materials are. Some manufacturers, such as 3A Composites with the Lucabond Plus, we also add other helpful information such as a timestamp of production. And that's to allow us to go back and review production records if ever needed and look at another way of quality control to make sure that everything was done properly.
Jeff, Nick mentioned the labeling is important to a fabricator. You're a fabricator. Can you give us your take on why it's so important?
Yes, Paul, the labeling is extremely helpful. I know here at CEI Materials, we fabricate well over 1 million square feet of MCM material annually, which means that at any given time, there's several projects flowing through our facility. By having the labeling on the back of the sheet, it helps to ensure that we are getting what we order. It also gives our operators one more quality assurance reference. Additionally, it provides reassurance to the end user that they are getting a product that meets specification and code.
Nick, the other thing that Andy mentioned was third-party testing and code compliance reports, and take us through why they're important, if you would, please.
Yeah, so again, per the IBC chapter or section 1703.5, third-party inspections are required, and that's really there to maintain a level of consistency. I look at it as the old saying, trust but verify type situation. The third party visits your plant annually, and they evaluate the material that you're producing is the same what you have tested. Sometimes you have to change a component of your material for various reasons, and that third party is there to evaluate that your material would still meet all of the same approvals and building code requirements. So, and sometimes when you change something that may seem small or insignificant, you might still have to retest all your materials due to that small change. It really helps the market is receiving what you're promising. An example of some of these third parties are like the ESR code compliance report, the ICC ES reports that many of us are very familiar with. Intertech does these as well. And again, they're really there to make sure that we're giving you what we are promising.
Well, it definitely seems like a good thing for manufacturers to produce what they've tested. So I'd like to switch to another topic now. I would like to touch on, as passed or approved wall assemblies, does every wall need to be tested? And this seems kind of impossible, Dan, given all the different potential designs.
So how much money you got? Because if you got a couple $100 million in decades worth of time, sure, we can test them all. But you're right, it's not realistic to test all the tens of thousands of potential exterior wall designs. I mean, just look at structural engineering, for example. When you're building a building, are you running it? You're not testing every single building structure. You're not testing the steel to see if it'll fail before you actually build the building. So we conduct an analysis, an engineering analysis to determine if the acceptable alternatives. Are there combinations of materials that, in our opinion, as engineers and consultants, are acceptable to what was tested? So there's two ways of showing 285 compliance in the eyes of the code. One is actually conducting a 285 test, and the other is having an engineering evaluation performed based on a successful NFPA 285 test when you're looking at alternate materials and designs.
Dan, what are these engineering evaluations and why are they needed? I'm sorry.
Yeah.
When should a project team pursue an engineering evaluation?
So I'll go back to your first question there, like what are the engineering evaluations and why are they needed? So engineering evaluations are a means of taking a successful NFPA 285 tested assembly and creating acceptable alternate conditions with different materials and thicknesses compared to what was tested. Now, these evaluations can take the form of a project-specific evaluation for a specific wall assembly for a specific building, or they can be generic evaluations. You see a lot of manufacturers with these that cover multiple building scenarios. We call them build-a-wall letters. They break down all the components that are possible combinations to show acceptance with NFPA 285. So these evaluations are based on the consultant's testing experience, like myself, our knowledge of the testing and the materials and the burning characteristics of the materials. And then we use that information to develop technical justifications for why these changes will not negatively impact the overall fire performance of the assembly. We haven't talked about cost of these tests, but they are expensive and they do take a lot of time. So these engineering evaluations allow manufacturers to be able to market their product in multiple configuration, but it also allows designers and building owners the flexibility when speccing out what they want to do and what they want the wall to look like to the contractors for bidding. Now, your second question, if I recall correctly, was about when should the project team kind of pursue these evaluations. In my opinion, and I write these evaluations all the time, the earlier the better. As the designer or building owner, start compiling a list of your exterior wall assembly materials that you're thinking about using. Try to get even a rough sketch of an exterior wall cross section and start to review them. See what's you're trying to do and see what information is out there for compliance. Reach out to the manufacturers, see if they have any 285 tested assemblies that match what you're trying to design and build. If they don't have a tested assembly that meets your needs, start going down the path of getting a formal engineering evaluation performed. A key thing to remember here is not every proposed assembly can be supported by an engineering evaluation. Not everything will work. So at the end of the day, if there's a combination of materials that can't be supported by an engineering evaluation, you're ultimately going to have to conduct the test anyways. So we try to come up and meet your needs, but sometimes we just don't have the data to support some combinations of materials. So testing is your only option.
Thanks, Dan. So does this engineering evaluation need other approval and is it officially allowed by the codes?
So at the end of the day, I could write a letter and stamp it with my PE stamp and you think you're good, but it all comes down to the AHJ. That authority having jurisdiction always has the final say if they'll accept an engineering evaluation or not. Some jurisdictions that I've worked with and worked in, they want to see a specific 285 test report for that building configuration no matter what, even if you have an engineering evaluation. Some will look at the engineering evaluation or the ICCES report and they're good from there. So it's important to understand where your project is, where it's located, what the vibe of the AHJ is to see what they've done historically. Is it allowed by code? Yes, absolutely. Section 104.11, alternate materials and construction method approaches is completely acceptable to use engineering evaluations to prove to the AHJ that you have testing and an engineering analysis to show that you would meet compliance with the intent of the code.
Thanks, Dan. So this is my last question before we get to our audience's questions, and it's a summary. In summary, what's the one major takeaway for trusting the NFPA 285? And I'm going to turn this to each of our panelists. Trusting the NFPA 285 and designing wall assemblies for North American construction. What's your one takeaway? And let's start with Andy.
Well, for me, the one issue that I'd like people to remember is that NFPA has been used for decades. NFPA 285 has been used for decades in the United States to show wall performance when it's exposed to a fire inside the building. This performance standard is proven to be very accurate, and we have not seen any major fires that have involved assemblies that have been tested. Could we choose a more difficult standard? Of course. We could add more fire, make a bigger sample, run the test for longer, but we have no experience that makes us concerned. We know that the exterior wall performs like the tested assembly. So it's a good indicator for high-rise construction.
Nick, let's have you go next. What's your major takeaway?
Yeah, so I think it's really important to see that the major fires that are really driving this concern, there's a right to have concern, but they're not representative of how we build in North America. Our codes, as Andy was just saying, are working as they were intended to drive safety, and we're all here to help you and anyone else meet these codes if you have any questions. So if you need assistance, you have those questions, please reach out to your local MCM sales representative or your local trusted fabricator, or even contact the MCM Alliance directly. We said that several times throughout the call. That's what we're here for. We're really focused on making sure that buildings are built correctly into these codes. And we know that it can seem confusing or sometimes difficult to navigate. So just reach out and get assistance in getting the answers, and we're there to help you make sure that your design meets that code that was intended for this life safety.
Thanks, Nick. Dan, your final thoughts on what's major takeaway?
Yeah, so my big takeaway for this is that NFPA 285, it's an assembly test, not a component test. Changing one element, even as simple as a water-resistive barrier within the exterior wall, can have major implications on the fire performance of the assembly as a whole. Now, that could be a positive change or that could be a negative change. It depends on what you're trying to do. Engineering evaluations, though, on the other hand, they're an important tool in providing alternate options without needing to test. But remember that you still might have to run a test at the end of the day. You might have to run that full-scale test if we don't have those technical justifications and those data points we need to support an alternate condition with an engineering evaluation. So NFPA 285 is an assembly test looking at everything together, and engineering evaluations are acceptable, but not always able to get the job done. That would be my big takeaway.
Thanks, Dan. Last word to you, Jeff.
Thanks, Paul, and thanks to my fellow panelists and all of the attendees. My key takeaway, NFPA 285, is a test that all in the industry believe in. And the effectiveness of this test is apparent by how assemblies that pass NFPA 285 have responded to fire. As an industry, it's important that we continue to educate everyone in the AEC community on the effectiveness of the test and the benefits of MCM as a cladding material.
Well, thanks to all of our panelists. You guys are great, and I just admire your expertise so much. Appreciate your time and effort again, as I said. Tom, let me bring you back in here for some closing comments and to handle our questions. I hope the audience has been firing away at you guys. Tom? Tom, I think you're on mute.
Yes, I was on mute there. Paul, thanks a lot. There's been a lot of good questions out there, and we'll get to those in a few seconds. But there's been a lot of great information given out today, and it's really hard to summarize everything. But we do have a few takeaways. I know you won't be surprised there. Number one, global fires out there have rightfully caused concern. And we have not had them in North America due to the focus of the IBC, the International Building Code, and the NFPA's safety and no threat to life requirements. Number two, involve a fire engineer early on in your project, particularly when you're going outside your typical wall design. For example, if you're designing a wall with a large cavity space, resolve that now, not later. And that's the best advice. And Dan was talking about that too. Get them on early. Number three, engineering evaluations are a great tool for designers, allowing flexibility for choosing the wall assembly components. As you can tell, there's so many different materials that can be used, and you have to have a good understanding of what's going on between those materials. These evaluations are based on good science, and the IBC allows them per section 104.11. So the NFP 285 test is a required assembly for materials with combustible materials. It's a very important aspect of the NFP 285. Number five, the MCM Alliance is a committee within the MCA, and we're focused 100% on MCM, particularly on the safety within the MCM designs. We're here to help you when you need clarity. Please reach out to the MCM Alliance, your local fabricator, or an MCM sales representative. We're only an email, and I'm old school, a call away. So in closing, I want to revisit the question asked earlier. Are we just lucky in North America? Well, I think by today's information here, luck has nothing to do with our current record. I think it's been shown today and for the last 40 years that this industry's earned the position with a lot of hard work by many driven and involved architects, engineers, fire consultants, manufacturer representatives, and fabricators, code experts. This is a very dynamic process, which counts on everyone's participation. My challenge to everyone on this webinar is to ask questions when you don't know, or something's not right. Speak up, because people's safety and no threat to life is at stake. Cutting corners is not an option for doing the right thing. Buildings are built with combustible products, but not all combustible products are equal. I think you heard that a couple times today. And as discussed, today must be tested accordingly and not to be used no matter what the savings. There's no savings when safety and no threat to life is the goal. Thanks again for attending today, and we really appreciate your focus and attention. Now let's get to a couple of these questions and hope we have enough time here. We'll make it. One of the first questions that came up was about spray foam, and it says here spray foam will not pass. Is that correct? Dan, I want you to answer that question. It's talking about all spray foams.
So spray foams, it depends on the application. It depends on what's being used. It depends on the veneer. Is it in the stud cavity? Is it on the backside of a precast concrete panel? There are conditions where spray foam will pass. It comes down to evaluation of all the other components. So my answer is it depends. Sometimes yes, sometimes no.
Okay. Do you happen to want to give a range of the cost for an engineering evaluation?
It depends on the complexity and the number of exterior walls.
Okay. So, hey, during the NFP 285 test, are sprinklers engaged as they would normally be in a building? Andy?
No, actually in the assembly itself or in the facility where tests is run, there are no sprinklers to regulate the fire inside the burn room. That's regulated by the amount of gas that's added to the room.
I want to piggyback up on that one real quick. So when you look at the building code is set up in two ways. And this is where fire protection engineering diverts into two directions. You have active fire protection and passive fire protection. Active fire protection being your sprinklers, fire alarm, notification devices, all that stuff. Passive fire protection, we look at the fire resistance rating of assemblies, the steel fireproofing protection, the building components themselves that are just going to sit there and do their job from day one. So when we're looking at NFPA 285, we want to ensure that this is the worst case scenario. Sprinklers aren't working. We don't have a fire alarm. We don't have any of those active systems that are meant to activate in an event. So by being conservative and ensuring that we're in testing to conservatism, we want to make sure that we're testing to worst case, and worst case for us in our mind, sprinklers aren't working.
Gotcha. Hey, Dan, along the lines with the engineering judgment, question came in there obviously with costs and things like that, but how long does it take to get an engineering judgment or evaluation?
So if you've selected your materials and you've got your design and you're like, hey, this is what we're going to go with, and get it to someone like myself, engineering evaluation, it could be done within a week or two. Sometimes it could take longer if you haven't specifically selected a material. You got to go back to your design team. Well, we need to specify this versus that, or we come up with the geometry or the materials aren't going to work in our opinion, and you might have to go for a test. So usually ballpark, we're at about internally about a 10 business day turnaround with an assembly that we can support.
Gotcha. Okay. Is it the MCM fabricator's responsibility to determine if an NFP 285 is required?
This is Dan. In my opinion, it's everyone's responsibility. Anyone that opens up IBC should be responsible to ensure that they're meeting the intent of the code. As Jeff might have said earlier, I believe he said that the MCM fabricators tend to be that final backstop. They're that final chance of, okay, the final check. It should be on the architect up front to make sure they're working with a compliant system. And Jeff, you can opine on that as well.
Yeah, Dan, we're looking at that right from the start when we're bidding the job. We see a lot of times where the project needs to be NFPA 285 compliant. The wall assembly warrants that, and it's not specified as such, or there's a wall assembly that wouldn't meet NFPA 285 requirements. And so we flag that and we bid it according to a code compliant system.
This is Andy. I want to piggyback on this one too and just say that in a lot of specifications and drawings that I've looked at and read, it says shall conform with whatever version of the IBC there is. But in the specification, they don't mention any NFPA 285 testing. Just because it's not mentioned in the specification doesn't mean that you don't have to comply. So keep in mind, to be compliant with the code overall in a lot of these high-rise buildings, NFPA 285, it's a requirement.
Absolutely.
Thanks. That's good responses there, guys. Some jurisdictions in Canada limit the use of MCM, including FR Core MCM, to 6-story buildings. What's the chance of that may become a code standard? Anybody want to take a wild guess at that?
Now, unfortunately, we can't do a feedback on what code they're talking about. If they're worried about that code restriction coming down to to the United States with the IBC, we just finished up the 2024 Group A ICC hearings, and there were no changes that would limit MCM or any other combustibles to 6 stories. So up until the 2024 code that is still in writing, I don't see that becoming an issue. And Andy, yeah. I know you were there too, and you can speak on that.
Yeah, I was thinking more from the National Building Code of Canada, the NBC, and there, as I said, it's a nationwide code, and then they put local amendments on it. There's a couple of the provinces that have said nothing above 6 stories. Those are kind of provincial, local amendments, if you will. I don't see it going to the national code at this point in time. I've been following the National Building Code of Canada, and I'm not seeing any proposals for that to take place across all of Canada. But I'm also not seeing it go away in the provinces that are already requiring that 6-story limitation.
Okay. One more question here. I got, how do you know that a product can carry the third-party listing for the NFP 285? Nick, do you got an idea on that one?
Like we
Nick, are
said,
you on
all
mute?
the ICCES reports are, I should be able to hear me. Can you hear me?
Yep.
Okay. So all reputable manufacturers should be able to provide you a third-party listing report where it would state if they were tested to NFPA 285. Additionally, you can reach out to those manufacturers and they'll be able to tell you what they were tested to, or potentially be able to provide an actual test that is often looked at as proprietary information. So they don't just share the test publicly, but many people will furnish it if actually requested. And the last thing is some manufacturers, I can speak for ourselves, have these engineering evaluation reports already created based upon the worst case scenario test. That's what we try to go test to. So that will allow the largest amount of flexibility in the design for the different components, such as the weather-resistant barrier or the insulation. So we try to always test worst case scenario to give the most options for the actual designers.
Okay.
And I will add that the acceptance criteria that we talked about earlier actually has the requirement for that listing there, as does the code. So both places say you got to have it.
Got it. So are you finding the FR products being required only on high-rise installations, or would they also apply to a single-story building?
And so I'll answer that, Tom, because I kind of was asked that question at the beginning with the PE and is it still manufactured? So
right.
Under certain scenarios, 1-story buildings are less than 40 feet. You can use a PE material instead of an FR if and only if there's not other combustible products in that wall. So for example, if you were going to use a polyiso and use MCM, no matter what the building height is, you need the FR. By and large, what I would say is at this point, 99% of our sales of our product that we produce is FR, because there's really not a whole lot of benefit to go with PE at this point in time. From a cost perspective, from many different perspectives, there's just not a reason for it. So we really focus on FR. Some manufacturers may look at it differently, but I can tell you that from our point of view, it makes sense whether high-rise or 1-story buildings to use FR material.
Yeah, and I'd like to add to that. This is Jeff. From the fabricator's perspective, we're seeing more and more specifications call for FR material. Our default is to always use FR, even if it's not necessarily required for that job. Being, it's a single-story building. There's no, foam plastic insulation behind it. We're typically pricing and fabricating FR material. Just the price point between FR and PE is so minimal. So to that, Nick, you said 95% of what you're seeing there is a Lucabond Plus. I would say 90% of what we're doing here is also FR rated material.
Yeah, thanks, Jeff. Hey, there's one more question I got here that's kind of interesting, and I'll fire it out, and whoever wants to answer it can take the first lead. But when you glaze a panel, when you glaze one of these panels into a curtain wall, storefront or whatever, how does that, impact with the NFP 285 testing? Anybody want to touch that?
I guess I'll start. This is Andy. I guess I'll start that one off. And really what you're looking at is you're looking at an engineering equivalency or an engineering judgment, because you've got to compare it to what's been NFPA 285 tested, unless the panels have been tested in the particular curtain wall assembly. If there's enough similarities to the materials that are used, the dimensionality, and all the combustible components, maybe somebody like Dan could write an evaluation that would cover it, and you're set. But in other cases, you may not have anything that's going to back up that use in a curtain wall application. So it's really going to be, using Dan's words before, it's really going to be job dependent. Dan, you want to add to that?
No, I think you hit the nail on the head there. Most of the time, we're not doing NFPA 285 tests on curtain wall assemblies, and I'm assuming the questioner is referring to kind of the spandrel areas where these MCM panels are being used. A lot of times we'll see those at the edge of slab to hide the perimeter fire barrier system. So
Right.
You're getting into an additional perimeter fire barrier test as well. Knowing that now you have, well, no combustibles, you've got aluminum curtain wall framing and glass, we can review back to go back to tested MCM 285 test reports and come up with, usually we can come up with an engineering evaluation. We also have to look at, okay, what are you doing behind that MCM panel? What kind of insulation are you putting in that spandrel area as well? So yeah, there's ways to do engineering evaluations, and we have seen a few curtain wall style glass and aluminum mullions and transom framings exterior wall tests. So there are some out there, and we can utilize those moving forward to review on a case-by-case basis.
Gotcha. Well, thanks guys for answering all those good questions. And if there are any we didn't get to, we can always respond to in writing. But Paul, I'm going to give this one back to you.
Hey, thanks, Tom, very much. And thanks to all our panelists. You guys, that was a great discussion and a ton of information. Really appreciate it. I hope our audience found it as valuable and interesting as I did. Thanks also to the MCM Alliance and Metalcom Live for supporting this event. And a reminder for all of you that you're going to receive an email in a couple of hours that will have a link to secure your AIA credits and download a certificate. So look for that. Thank you all for attending. You can see all our full webinar schedule at www.metalarchitecture.com. And everybody have a great, safe holiday season, and let's look forward to a happy new year. Cheers. Thanks.